We are now in a position to understand how to use truth tables for compound propositions. To construct a truth table for a compound proposition, first we need to determine how many different simple propositions make up the compound proposition. Then we build the truth table, assigning all possible truth values to the propositions, both simple and compound. Take this example. We have a compound proposition O.k. We'd like to find out the conditions under which such a statement would be true and when it would be false. Obviously, this would be very valuable information, particularly if O and K related to financial markets or investment decisions. We could tell when certain complex formulas would be true and when they would be false. So, how do we determine the conditions for the truth or falsity of O.k? By constructing a truth table that looks like this one. Once again, the left-hand columns remain the same, but on the right-hand side we have two columns. One for each statement connective, respectively negation and conjunction. Since the main connective is the conjunction, we have a black rectangle that outlines the values beneath the dot. We now know when the entire compound proposition will be true and when it will be false. It's true if and only if O is true and K is false. Let's take a more complicated example, this time with three simple statements combined into a conditional statement that has a conjunction as its antecedent and a negation in the consequent. Because we have three simple statements, H, M, and B, we'll need to have 8 rows in addition to the header row in our truth table instead of the usual 4. By the way, you can compute the number of rows you'll need in any given truth table by taking base 2 and raising it to the power of the number of simple statements you have. In this case, we'd have 2 to the 3rd power, or 2 times 2 times 2, which is equal to 8 rows. Notice the way we array the truth values on the left-hand side of the truth table. The top row has all true values, the bottom row has all false values. In between, we arrange the values so that they cover every possible combination. An easy way to ensure this is to start with the first column under H and alternate by groups of 4. In the next column, under M, we'll alternate by groups of 2. And in the last column on the left, under B, we'll alternate by every other one. On the right-hand side, we'll first have to figure out the values for the negation and the conjunction before we tackle the values for the conditional. As a general rule, we'll figure out the values for the statement connectives in ascending order, starting with the statement connective with the least scope, that is to say, the negation, moving on to the statement connective with the next greatest scope, that is to say, the conjunction, and then finishing with the main connective, in this case, the conditional or the horseshoe. I'd like to point out a few more things in the O.k example. Here we see that the right-hand side of the truth table is sometimes true and sometimes false, depending on the truth values of the component simple propositions and the logical connectives. We call such a proposition logically contingent, since it is neither necessarily true nor necessarily false. Here's an interesting statement. It contains no proposition other than B, which occurs twice, so its truth table looks like this. It's a contradiction. What are contradictions? They are compound propositions that are always false simply by virtue of their form. In a truth table for a contradiction, under the main connective, you'll see all F's. Tautologies are the opposite of contradictions. They are propositions that are necessarily true, as in the negation of this biconditional. You'll recognize it as the negation of the contradiction we just examined. Here's the truth table for the tautology. As you can see, it's all T's beneath the main connective. It's necessarily true. And here's a final note regarding tautologies and contradictions. If you negate a contradiction, you'll get a tautology. If you negate a tautology, you'll get a contradiction. This completes this lecture. Thank you.